Hi friends, in the last session we have discussed about a set data structure. Okay, we have started that set data structure. Okay, so just before we are going to description of data structure, first of all we have to understand what is set data structure. Just I will remind once and next I will explain what is set in detail with the practicals. Okay, so observe here first set data structure means if we want to represent a group of unique values as a single entity. Okay, if we want to represent a group of unique values as a single entity, then we should go for set data structure. Okay, next set elements represented by flower brace. Okay, set element represented by flower brace, that means this is the symbol. Next, duplicates are not allowed and insertion order is not preserved. When insertion order is not preserved, so we cannot expect to indexing and slicing the elements. But when insertion order is not preserved, but we can sort the elements based on our requirement. Okay, next, heterogeneous objects are allowed. So you know, right, heterogeneous means a different type of objects. That is, in set you can take int, float, boolean, anything. Okay, set allows everything. Okay, set allows heterogeneous objects. Next, set objects are mutable. Once we create set objects and we can perform any changes in that object. Okay, once we create set objects, we can perform any changes in that object. Okay, based on our requirement. And we can apply mathematical operations like union, intersection, difference, etc. on set objects. Okay, in normally in the list we have observed that concatenation we observed, right? So in the same way we can apply mathematical operations for set also, that is union, intersection, differences like etc. we can use on the set objects. Okay, this is the thing we have observed as part of in the last session. Okay, now observe each and every point in detail. So first we have to observe that creation of set object. Okay, creation of set objects. What is that? Creation of set objects. So what is creation of set objects means how can we create a set? Okay, how can we create a set? So how can we create a set means, see, observe here first point. Okay, first point is I'm taking s is equal to flower brace. Okay, I'm taking set is equal to flower brace. I'm printing that print s. I'm printing s and I'm printing type of s. Okay, I'm printing s and printing type of s. Observe here, I'm taking empty set. Okay, I'm taking empty set. So observe here, I'm printing that set and printing that type of set. Okay, so what is it type or something else? Okay, is it type or something else? Observe carefully. So if you observe here, it is considering as a dict. Okay, it is considering as a dict. Okay, so the conclusion is we cannot create a set objects by using we cannot sorry wait, we cannot create a set of we cannot create empty set object by using s is equal to this the way. If we consider, okay, if create by using we create by using s is equal to, in this way it will consider as okay, if we create set by using s is equal to in this way it will consider as a dict. Okay, it will consider as dict, not a set. Okay, it will consider as a dict, not a dictionary. I mean, it will consider as dictionary, not a set. Okay, it will consider as a dictionary, not a set. Right? So then how can we create a set? Then how can we create a set means observe here, I'm taking s is equal to set of, in this way. So now observe in this case, this time I'm getting the output as set and the type is also set. Here empty set I'm printing. This is the type. Okay, this is nothing but type. Okay, so this is the way we can create a empty set. Okay, this is the way we can create a empty set. X is equal to S is equal to set print of S, print type of S. Okay, this is the way, first way. Okay, this is nothing but first way. This is first way. Second way. Okay, second way. This is first way and this is the second way. So the second way is nothing but, okay, second way is nothing but creating element, creating set with the elements. Okay, second way is creating creating elements with the set. Okay, creating elements with the set. Creating empty set. Okay, creating empty set. Okay, creating elements with the set. So observe here. Here I'm taking set 10 comma 20 comma 30 comma 40 comma 50. Okay, 10 comma 20 comma 30 comma 40. So observe here, this time what is the output? Okay, this time also it will be a set. Okay, this time also it will be a set. Okay, this is the thing. Okay, this is the thing. Next point. Okay, next point. Okay, this is the next point. Next thing. Next point. So the next point is, we observed that if we want to represent a group of unique values as single entity, then we should go for set data structure. Okay, that's what we done here. Representing group of objects as a single entity. Group of objects as a single entity, then we should go for set. Okay, this is the information after printing, giving set. This is the information we are printing. Next, set element represented by flower brace. Okay, if you observe here, I'm printing the set elements by using in this way. Okay, this is the second point. Duplicates are not allowed. Okay, duplicates are not allowed. Okay, observe here, we'll try with the duplicates. I'm giving comma 10 comma 20 comma 30 comma 40. Okay, so except 50, remaining all are duplicates. Except 50, remaining all are duplicates. So now observe here, what might be the output. Okay, observe here what might be the output. If you observe here, duplicates are not available. Okay, duplicates are not available. That is, set won't allow duplicates. Okay, set won't allow duplicates. Set won't allow duplicates. Right? Set won't allow duplicates. Set won't allow duplicates. Next, next thing is, indexing and slicing are not allowed for the set. Okay. Okay. Before that, insertion order is not preserved. Okay. Insertion order is not preserved means, if you observed here, right? So the elements I am giving in this way. Okay. 10, 20, 30, 40. But if you observe here, in the same way elements are not printing. So that's what we, by using this, we can say that set elements does not follow insertion order. Okay. Set elements does not follow insertion order. Okay. The next point. Okay. The next point. But index in insertion order is not preserved, but we can sort the elements, that I will show in the future concept. Okay, that I will show in the future concept. You will get confused now if I explain. Next, indexing and slicing objects are not allowed for the set. Okay, indexing and slicing object are not allowed for the set. Okay, observe here, if I'm taking s of 10 I'm taking. Okay, s of 3 I'm taking. Normally s of 3 means what? This is 0, this is 1, this is 2, and this is 3. Okay, so now what we have to get? Error output 40, but make sure it will not give 40, it will give error. Okay, error will get error. See, observe here, type error, set object not subscriptable. Okay, set object not subscriptable. Okay, so set objects not allowed for the set. Okay, here observe here, indexing not allowed. And next thing, so when indexing not allowed, we cannot expect the slicing also. Okay, I'm taking that 0 to 0 to 3. Okay, 0 to 3 means in this way also will get error. Okay, in this way also will get a error. That means set objects is not subscriptable. Okay, set object is not subscriptable. So this is the one. Next, so here we can say that set objects won't allow indexing and slicing. Okay, a set object won't allow indexing and slicing. Set object won't allow indexing and slicing. Okay, set object won't allow indexing and slicing, right? Next, so the here what is the next point? Set objects are mutable. Once we create set objects, sorry, heterogeneous objects are allowed for the set. Okay, heterogeneous objects are allowed for the set means suppose here I have taken 10, 20, 30, 40, 50. Okay, 10, 20, 30, 40, 50. I'm taking one string. Okay, I'm taking one string, and one I'm taking boolean value. Okay, I'm taking one boolean value, and I'm taking one float value. Okay, this is the one I have taken. Okay, this is the one I have taken. Print of yes. Okay, print of yes. Print type of yes. Okay, I'm printing first print of yes, next print type of yes. Okay, I'm asking print yes, next print type of yes. 40, 10.5, 50, 20, 30, like this is the information we are getting. But if you observe here, the way in which way I have given the elements, but in the same way I'm not getting. Okay, it is varied from platform to platform. Okay, in my system, if I'm taking these elements, I'm getting this order. But it is not sure if you execute the same program in every computer, it will not give the same output. It is not sure. Okay, based on the system, output will change. Okay, based on the system, output will change, right? Next, set heterogeneous object allowed for the set. Heterogeneous objects allowed for the set. Allowed for the set. Heterogeneous objects are allowed for the set. Clear? Next, set objects are mutable. Okay, set objects are mutable. So how can you say set objects are mutable? Means s dot add. Okay, s dot add of what I'm taking means I'm taking one string, that is vision. Okay, I'm taking the string as a vision. Now observe here, s dot add of vision. So this is going to add in the given string. Sorry, print of yes, print of yes. If you observe here, vision is added here. If you observe here, vision is added here. So we can say that it is mutable. Okay, it is mutable. That means based on our requirement, we can add the string. Okay, based on our requirement, we can add the string. So example, based on our requirement, we can add the string. Based on the requirement, in the requirement, we can add the content. So we can say that we can say that we can say that based on our requirement, we can add the content. So we can say that set objects are mutable. Okay, set objects are mutable. Okay, set objects are mutable. Okay, so this is the thing. Next, we can apply mathematical operations like union, intersection, differences, etc. on set objects. Okay, this is the mathematical operations concept. There I will explain this concept. Okay, next, we cannot create set objects by using s is equal to empty flower base. If we create by using s is equal to, but it will consider as a dictionary, not a set. Okay, so this is nothing but set data structure. Okay, just I will revise one more time. This is the first way of creation, empty set. Okay, creating elements with the set. Okay, next, set won't allow duplicates. So if you observe here, I am giving more duplicates, but in the output we are not observing. Next, set objects won't allow indexing and slicing. Okay, if you observe here, I am using indexing, and if here I am using slicing. Okay, it is not allowing. Next, based on our requirement, we can add the content so that we can say that objects are mutable. Okay, so that we can say that objects are mutable. Okay, so this is nothing but set data structure, right? So in the next session, I'm going to explain about the important functions of set. Okay, in the next session, I'm going to explain about the important functions of set. Okay, thank you friends. Thanks for watching this video. If you are having any questions or queries, please post your query in the comment section or reach out to my email ID in the given description. Thank you friends. Thanks for watching. Please subscribe to my channel if you are watching for the first time. Thank you.